There we go. Right. Guess. Right. Yeah. So, well, I can add stuff on the machine now. And but obviously we wanted to do more than that. So gonna move on. Hopefully soon we'll be able to save variables and use them later for any reason, really. It's a bit warm. Okay, so let's get started, I guess. In the previous 2 chapters, we learned a lot of new and strange things. Yes, indeed. Built a tiny compiler, virtual machine, and defined bytecode instructions. Excuse me. This one will use our newfound knowledge of bytecode compilation and execution and combine it with what we know from the first book to add support for all infix and prefix operators. Yep. I mean, the rest of it should really be the same. It's just the operator that changes, right? Besides, we have... yeah, there is some cleaning up to do. In the current state, the only thing our compiler and our VM are capable of is adding 2 numbers, give them the expression 1 plus 2, and our VM will correctly put 3 on its stack. That's exactly what we want. But there's one issue lurking in the shadows. Lurking in the shadow. But 3 stays on the stack and will stay there for all eternity if we don't do something about it. Right, yes, because the stack would eventually fill up. For instance, if you get the REPL running and if I add enough expressions. Yeah, that's not good. Problem is not with the expression, but rather where it occurs. It's part of an expression statement. I mean, yeah. The first let statements, return statements, and expression statements. First 2 explicitly we use the value of their child expression nodes. To use the value their child expression nodes produce. Expression statements merely wrap expressions so they can occur on their own. Yep. The value they produce is not reused by definition. Now a problem is that we do reuse it because we involuntarily keep it on the stack. Take a look at the following monkey program. Here, if we would just fill up the stack with 3 separate statements. Yeah. and it would just fill up the stack over time. We need to do two things. First, we need to define a new opcode that tells the VM to pop the topmost element of the stack. Second, we need to emit this opcode after every expression statement. Interesting. Okay. Pop-up. Add a new opcode. Pop-up will be, I guess we have a method already. Yeah. I mean, this is quite easy. Oh, okay. If it's a single statement, should be at the, should have two. No, these are two statements. Yeah, there should be two. Yep. Just here. That's it, really. That's the only change. Oh no, we gotta actually pop it from the stack to. Where would we do that? Statement. Hang on. Let me check my VM. Guess I need code. Compile. Oh yeah, right here. Okay, that didn't seem too bad. Yeah, that's super easy. Okay, I think that's good. Do we need the element? We have the stack pointer. Ah, right. Oh yeah, because they're still accessible. Because it's an array. That would make for a better test as well. Okay. Now VM, blah 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 blah. It should have been on the stack right before you popped it off. In order to do that, we had a test only method. Okay, that's what he's trying to do as well. As per our convention. Fuck. Fans making weird noises. Ooh, it's a bit cold now. As per our convention, vm.sp always points to the next free slot in vm.stack. This is where a new element would be pushed. Yeah. Since we only this is where we can find the elements that we previously on top of the stack. Okay. Yeah. Oh, okay. At the end of that makes sense. Virtual machine tests. Okay, you just add a new. And I suppose you might need to update the previous test as well. So here, would that mean, let's say you add two numbers. Unless you return, you'd have to get the value by checking the top of the stack. I guess it makes sense for like expression statements because they really do nothing. Yeah, unless it's a function call, in which case they do something. Okay, guess I know what to do. Need to add hop, hop, and suppose this is fine. Don't need to add a test for it, but seems unnecessary. Right, and in compile statement, what do we call make? Okay, where do we call emit? Huh, just realized. Infix. I need to check, not expression, AST expression. call expression. Now if I switch E, will this be a pointer? Hang on. Oh no, I don't need to worry about it. Dot expression state. Fuck, it's not an expression, is it? Yeah. Already have it. Silly me. Here's dot expression. That is interesting. Can't do it here because not every expression is an expression statement, is part of an expression statement. Self dot oh, okay. Fuck. Simple. Does it add a? No, it doesn't. It kind of does. Self dot emit code dot code dot up pop. And it takes no operands. Catch return compiler error dot out of memory. Yeah. Okay. So now the compiler has the statement. We need to add any test. Yeah. So this is an expression statement, so there should be up pop. Is that the only test here? Yeah. Okay. See, sig test does large source. Can I just do compiler.zig? Fair enough. Source compiler. Switch must handle all possibilities. Okay. Code. What line was it? 12. Code. Can I not just do that? Dot up definition. Name is pop, then operand width is nothing. Okay. Now, when the virtual machine runs, okay, so these are all statements, expression statements. Yeah, expected int. I guess we need another method. This doesn't need to be public. Lost opt text VM and an object dot object. Just realizing should this error instead of returning null? Let me see where we call this method. Guess so far it's only on the test. And self dot stack self dot sp. Then instead of stack top, last popped. Is that it? I guess one way to find out. Zig test source virtual machine.zig. Okay. Line 30. Up, pop. Guess there's a pop method. Okay, it's easy. Where was I? Yep. Try self dot Just excuse me. What does pop do? Okay, it also returns, which don't need. Do I need to discard? I will find out. Source. Yeah. Guess I don't need the value. Let's go. That was easy. Clean up stack after object lifetime. Sounds fancier when I say that. Okay, so that should be all of that. Done. What's this? Oh, I thought it was a test only. REPL. Should be a better way to do it, but last popped. Guess this needs to be public. Check. Sig. Build. Run. Okay. All right. Hopefully we get a few easy ones today. I like this. Okay. I guess this I can do. Code. Is it sub divide? Okay. Support the rest of it. Code. Sub. Multiply. Divide. Sub. Multiply. Divide. Sub. Change. This should be multiply. This should be divide. Okay. Yep, none of them take any operands. Make remains the same. Opcode, operand, expected bytes. Yep, I guess I could just add to sub. then guess sub multiply and then divide. Okay, sig test. What's that file called? Source code. Okay. And then in the compiler, I just got to run the test. I know some switch statements might fail. Oh. Really? That is strange. Oh, okay. Because here, what is plus? Plus minus asterisk slash. Minus asterisk slash. Minus sub asterisk. Yep. That is up multiply slash. That's going to be divide. Okay, I'm hoping some failed. Nothing. Okay. Guess. Okay. I can add some tests. Sub multiply. Fuck. Did I put it inside? Sub multiply divide. The indentation looks a bit weird. Okay, never mind. Plus minus sub. I think we don't care what the output is here. Multiply. The operands remain the same. Yes. Then slash the divide. The test still pass? Yeah. Okay, so now all that's left to do sig test source VM. Yep. So for all three or four, I first need to get the operands, and the only change is here. And I also think this should be operand Does the order matter? I think it does. So whatever got popped. It's 4 plus 5. No, it's correct. Is it? Yeah, if it's 4 plus 5, 5 gets pushed to the stack last. So this should be, yeah, 2 plus 1. Let me see, how can I handle multiple cases together? Okay. And can you use this value somewhere? Is it? I don't think it's a tag union. Yeah, it's just an enum. What I could do is definition. Could expand this. So what I'm thinking is I can do up sub, up multiply, and up divide. And based on can I do I mean that is if I don't want to copy the code over. I could make this a method on the virtual machine. What would this look like? B or should I just like copy it? Alright, let me make the test pass and then I'll come back to it. Subdivide. Doesn't feel right, but I guess it's fine. Sub minus, oops. Where's fucking plus? Should be divide and then this, not sub, sorry. Multiply. And in the test, sub, multiply, divide. Okay. Guess I can get rid of this. No. Minus. Then there's only integers at the moment. There's no float. Equal to 6 by 2. Division with I64 and I64. Right, okay. What? Well, I've never seen that before. Div wrong. What are the options? Trunk, floor, exact. Trunk, floor, exact. Okay. Color guarantees denominator 0 and div trunk numerator denominator times denominator equals numerator. Color guarantees. Well, I can't guarantee that. Flawed division, truncated division. Just realized. How do you declare floats in Zig? Primitive types. Okay, with an F. Okay. Right, so div trunk. I can't guarantee. Can't use div exact. So it's one of these. Float division round towards negative infinity. Call guarantees denominator not equal to 0. Yeah, I think that's fine. Should error. Or I could handle that error in the compiler. Compiler or runtime error. Divide by 0. No, not here. Divide. If operand 1 dot value turn runtime dot divide by 0. Could be an assertion as well. I think it should be an assert. Because if this happens, something's gone very wrong. Operand 1, the value not equal 0. I was checking. I want to check if you can send a message. I don't know. Should it be an error? Oh, leave it as an error for now. And then what was div trunk? Truncated division rounds towards 0. For unsigned integers, it is the same as numerator divided by denominator. Call it guarantees denominators not equal to 0. For a function that returns a possible error code, use. Okay. Guess I can use trunk. Numerator, denominator. Turns t. Trunk. Okay. No surprise there. Should I check for error? Okay, I can just make the test fail. Okay, I'll do. Now, yeah. Alright, let me see what. Well, the only thing I can think of is called pop2. Have a method to get the last two. Does Zig have tuples? Created without specifying field names and are inferred to as tuples. An empty tuple looks like that. Hey Taras, how you doing? Destructuring tuples. Yeah, how do you do that? Nice, good to hear. Yeah, it's well, no, early Sunday for me. That's weird. Hello from the future. Oh yeah, I can destructure them. Hang on, how did 1 plus 2 plus 3 work? Oh yeah, because you always do infix. Yeah. Okay, seems a bit unnecessary. Could just move it to a method, but okay, it's fine. Yeah, done. Done. Whoa. Yeah, that's done as well. I don't remember doing this. Oh no, I do. Just use the enum. Yep, that's done. I guess I could expand it. Let this one. D5. Yep. I mean, I don't see why it should fail. Okay, done. Well, not what I was thinking, but I'll leave mine as is. I don't like, I mean, it looks nice, but I'll leave mine as it is for now. Actually, one thing that I could do is nah, because then I need another switch statement in here. Nah, I'm just gonna leave it as is. Fine. Booleans. Okay. Guess how would booleans be different? Booleans. You know what, Taras? I'm feeling quite lazy as well. I feel like done. What's not compile? What's the word? Support rest of arithmetic, I guess. Operators. Yeah, I think I'll go have a lazy Sunday as well. I'll get to booleans tomorrow. Guess booleans are not so bad either. Yep. Yeah, you just, yeah, it's super easy. I can do this tomorrow. It's fine. Okay, I guess I'm gonna go enjoy the rest of my Sunday by doing mostly nothing. And hope you have a good weekend as well. I shall see you tomorrow. Bye. Have a good day. Bye bye.